The Tunisian winter of 1943 was a season of mud and momentum. The tide of the North African campaign had turned decisively at El Alamein, and now the combined forces of the British 8th Army and the American 2nd Corps were pressing the retreating Axis forces into a shrinking pocket of resistance. The landscape was a churned-up testament to the war's passage. Burned-out husks of Panzer IVs, abandoned Italian M1340s, and the skeletal remains of supply trucks littered the stony, arid plains. For the forward patrols tasked with mopping up and securing territory, the sight of another wreck was as commonplace as the scorpions that scuttled beneath them. The patrol in question was a section of the 1st Derbyshire Yeomanry, a reconnaissance unit operating ahead of the main Allied advance near the town of Spatla. Led by a weary but vigilant sergeant named Tom Perkins, they were navigating a narrow, rocky defile, their universal carriers grinding through the thick, cloying mud. The air was cold and carried the lingering, acrid smell of cordite and diesel. It was the sharp eyes of Private Jimmy Fletcher, a former farmhand from the Peak District, that spotted the anomaly. "Sarge," he called, pointing with a gloved hand towards a cluster of large boulders. "Over there, something's off." What they initially took for the rear of a German SDKF 251 half-track quickly revealed itself to be something else entirely as they drew closer. It was a wreck, that much was clear. It had taken a direct hit, likely from a fighter-bomber's cannon, and then careened off the track and into the rocks where it had burned. The metal was blackened and twisted. The rubber of its tires melted into grotesque frozen pools. But the silhouette was wrong. It was too low-slung, too angular. The engine compartment was at the rear, unlike the forward-mounted engine of the half-track. The tracks, what remained of them, were wider and of a different design. Perkins dismounted, his Thompson submachine gun held at the ready, his boots sinking into the mud. He circled the wreck slowly. The paint, where it hadn't blistered away, was a strange mottled gray-green, not the standard Dunkelgelb. There were markings, but they were unfamiliar. A stark black geometric symbol, a circle bisected by a vertical line, stenciled near the front. It wasn't the German cross, nor the Italian tricolore. It was something else. "Jerry's getting creative," Fletcher muttered, poking at the wreck with the barrel of his rifle. "Or desperate," Perkins replied, his brow furrowed. He knelt down, peering into the torn-open crew compartment. It was a charnel house of melted wiring and shattered instrumentation. The layout was sparse, utilitarian, but with panels and dials that seemed more complex than those in a standard armored vehicle. This wasn't a troop carrier or a tank destroyer. It felt scientific. It was as he was completing his circuit, his gaze sweeping the ground, that he saw it. Partially buried in the churned-up mud and sand, half crushed under the mangled rear track assembly, was a small rectangular metal plate. It had likely been mounted on the vehicle's hull before the explosion tore it loose. He bent down, pried it free, and wiped the grime away with his thumb. The inscription was stamped in clear block letters. It was in German, "Nicht einfangen," prototype. Perkins' German was rudimentary, picked up from intelligence briefings and captured documents, but he knew enough. Nicht meant not. Prototype was obvious. His blood, already chilled by the desert cold, seemed to freeze solid in his veins. He looked from the plate in his hand to the strange silent wreck and then back again. "Fletcher," he said, his voice unnaturally calm, "get on the wireless to battalion, now. Tell them we have a Category Alpha recovery. I repeat, Category Alpha. No, I'm not joking. And tell them the message is, do not capture, prototype." That was the moment, in a forgotten Tunisian wadi, that Allied intelligence stopped breathing. The war, for a few key individuals, had just changed. The journey of the wreck from the Spatla defile to a secure engineering depot outside Algiers was a lesson in clandestine logistics. It was covered in tarpaulins, loaded onto a specially designated low-loader truck under heavy guard, and transported under the cover of darkness. Its existence was known to a handful of people, its classification level set at a tier above top secret. It was now designated Object Tango 1. The depot was a former French aircraft hangar, now surrounded by a triple layer of barbed wire and patrolled by hard-faced MPs with orders to shoot intruders on sight. Inside, under the harsh glare of arc lights, the wreck was reassembled, as best as possible, on a wooden cradle. Around it stood a small, hand-picked team of the Allies' most brilliant and unconventional engineering minds. There was Professor Alistair Finch, a Cambridge Don and radar expert, who had been whisked out of his laboratory with no explanation. Next to him was Major Anna Rosenberg, a U.S. Army engineer with a pre-war background in automotive design and a fierce analytical mind. Completing the trio was a quiet, intense man named Eris Thorne, a Swiss-American specialist in mechanical propulsion who had been consulting for the Office of Strategic Services. They gathered around Tango 1, not as soldiers, but as academics confronting a perplexing artifact from a future they didn't understand. The air in the hangar was thick with the smells of cold metal, burned-out insulation, and a palpable sense of intellectual tension. "It's a Frankenstein," Rosenberg stated, her arms crossed as she surveyed the wreck. "A bloody Frankenstein." She was right. The initial external assessment confirmed it. The engine, a compact, horizontally opposed 12-cylinder diesel, was unlike any German design they had ever seen. Its construction was incredibly lightweight, using alloys that were rare and expensive. The manufacturer's stamp, where it could be read, was from a Czech firm known for precision instruments, not tank engines. The chassis was a hodgepodge. The suspension components bore the markings of a French factory in the occupied territories. The transmission housing was Italian, from a Fiat Ansaldo plant. The electronics, what remained of the charred wiring looms and shattered glass valves, were a bizarre mix of German standard components and others that followed no known electrical convention. This wasn't a troop carrier or a tank destroyer. It felt scientific. The most intriguing and disturbing feature was a large, sealed compartment located just behind the driver's position. It was a box of thick welded steel, roughly the size of a small desk, and it was bolted shut with a dozen large, custom-made bolts. It had survived the crash and fire remarkably intact. There were no visible access panels, no service hatches, just a cluster of heavy-duty electrical conduits and what looked like fluid lines leading into it, all sheared off in the crash. "What in God's name is in there?" Thorne wondered aloud, running a hand over the cold, unyielding steel. "The do not capture order suggested they were terrified of us finding out," Rosenberg replied. "This isn't just about protecting a new tank design. This is about protecting a secret." For days they worked, disassembling the non-classified parts of the vehicle, cataloging every component, every screw, every wire. They X-rayed the sealed compartment, but the steel was too thick, the internal structure too dense to reveal anything. They were building a blueprint of a machine that officially had no blueprint, reverse engineering a ghost. The answer, when it came, was not from the main compartment, but from a secondary, smaller electronics bay that had been partially shielded from the fire. Inside, amidst the charred remains of what was clearly a sophisticated data recording system, they found a metal cassette. It was a data storage medium, a type none of them had ever encountered. It took Finch another 2 days and the cannibalization of several pieces of captured German radio equipment to rig up a reader. The data, once they managed to access it, was fragmentary, corrupted by heat and shock, but it was enough. It contained reams of telemetry, temperature readings, power output levels, vibrational frequencies, and it contained logs, test logs. Professor Thorne was the first to piece it together. He had been analyzing the unique exhaust system and the strange oversized cooling fans. He compared the data from the cassette with the physical evidence. "It's a turbine," he said one evening, his voice hushed, the single light bulb over their workbench casting long shadows across his face. The room fell silent. Gas turbine technology was in its infancy. The Allies knew the Germans were experimenting with it for aircraft, the nascent jet engines, but to put one in a ground vehicle? It was preposterous. It was thirsty, temperamental, and required exotic materials. Yet the evidence was undeniable. The sealed compartment wasn't a weapon, it was the power plant. a revolutionary engine that promised unheard-of power-to-weight ratios and potentially incredible speed. But that revelation only led to a more profound and terrifying question. The vehicle itself, Tango 1, was clearly just a platform, a means to an end. It was designed to collect data on this new engine's performance under battlefield conditions. The question hanging in the smoky hangar air was the one that would keep Allied generals awake at night. The sealed compartment became an obsession. It was the locked chest at the heart of the mystery, and its impenetrability was a constant, silent taunt to the team in the hangar. For days, they debated how to open it. Drilling risked damaging whatever was inside. Torches were out of the question. The risk of explosion or chemical release was too high. In the end, it was brute force and patience that won out. Using large, carefully calibrated wrenches, they began the painstaking process of loosening each of the 12 large bolts. The screech of protesting metal echoed in the vast space, each turn a small victory against the German engineers who had so clearly never intended for this box to be opened by enemy hands. When the final bolt was removed, there was a moment of collective hesitation. Professor Finch, his hands smeared with grease, looked at Rosenberg and Thorne. Right then, moment of truth. With a grunt, he and a burly RAF technician pried the heavy steel lid upward. It came away with a groan, revealing not the expected nest of high explosives or vials of some deadly gas, but something that at first glance seemed almost mundane. Nestled within a custom-fitted cradle of shock-absorbent rubber was a machine. It was about the size of a large suitcase, a complex assemblage of wires, vacuum tubes, and delicate, clockwork-like mechanisms. At its heart was a slowly spinning metal drum, similar to those used in early analog computers. But it was the drum's surface that drew their immediate, confused attention. It was covered not on punched tape or magnetic wire, but on a fine, translucent sheet of what looked like celluloid. And on this sheet were intricate, hand-drawn charts. Rosenberg, her engineer's mind seeking order, was the first to lean in. They're graphs, meteorological data. She pointed with a pencil. This axis is altitude. This is atmospheric pressure. These markings here, temperature gradients. Finch, the radar man, adjusted his spectacles. But it's too specific, too targeted. Look at this layer here. It's not just measuring the weather, it's measuring how the weather bends radio waves. He traced a series of curving lines that represented not air pressure, but signal refraction. And these EM reflections, this is about radar clutter, how much natural noise there is in the atmosphere at different altitudes and under different conditions. Thorne, who had been studying the machine's mechanical linkages, chimed in. The machine itself, it's a data correlator. It's not just recording this data, it's cross-referencing it. Look at this cam assembly. It's designed to find the optimal relationship between, say, humidity, air pressure, and something else. He pointed to a third set of inputs on the charts, a series of wavering lines that denoted low-altitude turbulence patterns. The pieces began to click into place with a terrifying, logical precision. The strange engine was necessary to power this bank of sensitive equipment. The mobile test bed was needed to gather this data not in a laboratory, but across the varied terrain and atmospheric conditions of a real battlefield. This wasn't about creating a new tank. This was about understanding the sky itself. One of the junior engineers, a young lieutenant from MIT, finally gave voice to the dawning horror. He stared at the spinning drum, at the beautiful, deadly logic of the charts. "My God," he muttered, his voice barely a whisper but cutting through the hangar's silence like a shard of glass. "This looks like early radar avoidance research." The words hung in the air, thick and suffocating. Everyone in the team understood the implication instantly. The air went out of the room. Radar was the Allies' single greatest technological advantage. It was the shield that had won the Battle of Britain, allowing a handful of Hurricanes and Spitfires to be vectored onto massive German bomber streams. It was the eye that guided night fighters over Europe. It was the Sentinel that watched the coast for the threat of invasion. The entire Allied defensive strategy, from the tactical to the strategic, was built upon the foundation of radar. If that eye could be blinded, even partially, the entire edifice came crashing down. The discovery transformed the mood in the hangar from an intellectual curiosity to a frantic, grave urgency. The data from the cassette and the charts on the drum were rushed to a dedicated analysis team, a group of the best physicists and meteorologists Allied intelligence could muster. They worked around the clock, fueled by coffee and a cold, creeping fear. It was during this deeper analysis that the second, even more terrifying layer of the nightmare was uncovered. The team, now led by a brilliant but perpetually anxious Oxford physicist named Dr. Bennett, was building a profile of the technology. They expected to find the hallmarks of a single, dominant design philosophy: the brutal, over-engineered efficiency of the Germans, or the simpler, functional approach of the Italians. But the profile was a schizophrenic mess. The core data correlation concept was sophisticated, theoretical, bearing the fingerprints of pre-war German physics institutes. But the execution was a patchwork. The delicate sensor arrays had manufacturing stamps from Swiss firms, neutral but known to sell to the highest bidder. The specialized vacuum tubes, capable of handling specific high-frequency signals, were of a type produced in small, specialized batches in occupied Holland. The housing for the main processing unit used an aluminum alloy that was primarily sourced and worked in French factories under German control. Professor Finch laid out the evidence on a large table in the command center, now established in a sandbagged room adjacent to the hangar. Components were grouped not by function, but by their suspected country of origin. It looked like the inventory of a multinational junkyard. "It's not Axis designed," Finch stated, his voice tight. "It's compiled. They've taken the best available components from across their sphere of influence and cobbled them together to test a single unified concept." Major Rosenberg picked up the thread, her finger stabbing at a map of Europe. "They're not trusting this to any one ally. The Germans don't trust the Italians with the full picture. The Hungarians or Romanians wouldn't have the technical base. So they're farming out the production, keeping the overall goal, the why, a secret even from their partners. They're building the pieces of a jigsaw puzzle in different rooms and only assembling it at the very end." Dr. Bennett, who had been silently staring at the component map, looked up, his face pale. "Which means only one thing," he said, his voice hollow. "This isn't a pet project of the Luftwaffe or a side experiment by the Kriegsmarine. This is a strategic-level, collaborative Axis effort. They are pooling their resources, their brain power, across national lines to solve the one problem that could win them the war: how to make their aircraft invisible to our radar." The command room, filled with senior officers and intelligence officials, erupted. Shouted questions, curses in 3 different languages, the sound of a fist hitting a table. The nightmare was no longer a technical curiosity. It was a strategic cataclysm in the making. The fragmented, often distrustful Axis alliance was, for this one critical goal, working in concert. If they succeeded, the Luftwaffe could once again fly with impunity over Britain. Their U-boats could become even more elusive ghosts in the Atlantic. The entire Allied defensive strategy, a carefully constructed house of cards, was facing a wind that threatened to blow it to pieces. The race was no longer just about understanding the machine. It was about finding a countermeasure before the enemy could deploy the technology it was designed to create. The clock, which they hadn't even known was ticking, was now screaming in their ears. The atmosphere in the analysis room was that of an academic seminar teetering on the edge of panic. Dr. Bennett and his team had laid out the translucent charts from the spinning drum on a massive light table, their intricate lines glowing like a malevolent nervous system. For days they had pored over the data, cross-referencing it with known meteorological records and Allied radar performance logs. The puzzle was immense, a 3-dimensional chess game of physics played out in the sky. The breakthrough came not with a shout, but with a slow, dawning horror. A junior physicist, Eleanor Vance, had been tasked with mapping the recorded atmospheric density and pressure gradients against instances of known radar ghosts, false returns and unexplained fades that had bedeviled operators for months. She worked in a corner, surrounded by stacks of operator logs from chain home stations along the British coast. "Sir," she said, her voice unnervingly calm, "I think you need to see this." They gathered around her desk. She had overlaid one of the German charts, which detailed the specific set of conditions over the English Channel from the previous autumn, with the log from a radar station at Ventnor on the Isle of Wight. On the night in question, the Ventnor operators had reported a 15-minute period of severe signal degradation, which they had attributed to a sunspot event. The German chart, however, told a different story. It showed a precise, transient layer of warm, dry air sitting atop a cooler, moister layer, a perfect temperature inversion. According to the German data, this inversion created a duct, a natural waveguide in the atmosphere that could trap radar energy, bending it upward and over the horizon, leaving a blind spot in the low-altitude coverage. Professor Finch, examining the data, felt a chill that had nothing to do with the desert night. "He's close," he said, his voice grim. "They're not just theorizing. This data, it's operational. They're validating a model. They're dangerously close to being able to predict when and where these blind spots will occur. They could schedule a bombing raid to coincide with a predictable atmospheric flaw." The implications were paralyzing. The Allies now knew the Axis plan with terrifying clarity. But the most frightening part was the cold, hard truth of the physics. It could work. The captured machine had proven it. The atmosphere does indeed have these vulnerabilities. The science is sound. The enemy is on the cusp of turning a meteorological curiosity into a war-winning weapon. The report that went up the chain of command was the most alarming document of the war to date. It bypassed normal channels, sent by an encrypted teletype directly to the War Cabinet offices in London and the Pentagon in Washington. It described not an enemy weapon, but an enemy understanding. An understanding of the electromagnetic spectrum that was about to render the Allies' primary defensive shield obsolete. The response was not panic, but a tsunami of controlled, decisive action. Within hours, a series of top-secret directives, codenamed Operation Sky Shield, were issued with an urgency usually reserved for an imminent invasion. The first and most immediate order was a complete recalibration of every frontline early warning and gun-laying radar set in Britain and the Mediterranean. Technicians worked around the clock adjusting frequencies and sensitivities based on the German data, trying to see around the predicted atmospheric ducts. It was a desperate attempt to patch a software bug in the very sky. Simultaneously, emergency training programs were launched for every radar operator. They were no longer just looking for blips, they were now hunting for absences. They were taught to recognize the signature of an atmospheric blind spot, a sudden unnatural clarity in long-range returns coupled with a dead zone at medium altitude. New protocols were established for reporting ghost returns and anomalous signal fades. What was once dismissed as weather was now treated as a potential prelude to attack. The tactical response was equally swift. Night fighter patrols over potential target cities were dramatically increased. The Mosquito and Beaufighter squadrons, the scourge of the Luftwaffe after dark, were now flying standing patrols, their own airborne radar tasked with filling the gaps that the ground stations might miss. The balloon barrages around key industrial centers and ports, once a static defense against low-level attack, were expanded and reinforced. It was a physical, steel cable wall to catch any raiders that slipped through the electronic net. But the most profound shift was in research and development. The captured data provided a priceless negative image of what the enemy was pursuing. Allied scientists, now knowing exactly what to look for, launched a massive crash acceleration of microwave radar research. The longer wavelengths used by existing chain home stations were more susceptible to the atmospheric bending the Germans were exploiting. Shorter, centimeter microwave radar, a technology still in its infancy, was far less affected by these conditions. Projects that had been languishing in laboratories were suddenly given unlimited priority and funding. The cavity magnetron, a British invention that was the key to practical microwave radar, went from a promising prototype to a tool of national survival. For the first time in the war, Allied radar strategy was not reacting to enemy actions, a new bomber, a new jamming technique, but to an enemy idea. They were fortifying their defenses against a threat that had not yet fully materialized, based on the blueprint found in a single battered machine. They were fighting a ghost, a theoretical menace made terrifyingly real by the data charts from a Tunisian wadi. The element of surprise, that most precious of military commodities, had been irrevocably lost by the Axis. Their grand project, a secret they had guarded by scattering its construction across a continent, had been laid bare by a single, unlucky crash. The race was now a desperate sprint. The Allies were shoring up their defenses, working feverishly to nullify an advantage before the enemy even knew they could use it. The wreck of the prototype had not just given the Allies a warning, it had given them a head start in the most critical technological arms race of the war. The battle for the skies had just been fundamentally and permanently altered. The mangled husk of the prototype, now stripped to its skeletal frame, sat silently in the corner of the hangar. Its work was done. The flurry of intense activity that had surrounded it for weeks had moved on, transferred to map rooms, radar stations, and research laboratories across the Allied world. In the end, Object Tango 1 was just that, an object. A collection of strange parts, a bizarre engine, and a sophisticated data recorder, all scarred by fire and war. It was small, broken, and tragically incomplete, but its legacy was immense. It had served as a perverse oracle, a captured glimpse into the enemy's most ambitious laboratory. The intelligence derived from its innards was not a new bomb or a faster plane. It was a concept, a terrifyingly elegant concept that forced the Allies to confront a fundamental vulnerability in their most critical defensive system. They had been building walls, and the enemy had been learning to walk through them. The prototype revealed the blueprint for that invisible door. The immediate operational impact was a dramatic sharpening of the entire Allied air defense network. Radar operators, once trained primarily to identify and track contacts, were now also trained as meteorological detectives. They learned to read the sky not just for weather, but for electronic weather. A sudden, unnatural fade in returns from a specific altitude band was no longer dismissed as atmospheric interference. It was a red alert. Operators from the cliffs of Dover to the islands of the Mediterranean began reporting these anomalies with a new, educated urgency. The system, once reactive, was now proactive, its human components hyper-aware of the environment in which they operated. This new awareness led to a continuous process of refinement and recalibration. The massive chain-home towers, the stalwarts of the Battle of Britain, were fine-tuned. Their sweep patterns were adjusted, their frequencies subtly shifted in response to the German data on atmospheric ducting. It was a constant game of electronic cat and mouse, but for once, the cat knew the mouse's intended path before the mouse did. Radar detection ranges became more reliable, and more importantly, the why behind the occasional failures became understood. Knowledge replaced superstition. An operator who understands why his screen has gone momentarily blank is infinitely more dangerous than one who simply curses his equipment. The most profound change, however, was in the laboratories. The captured data provided Allied scientists with a priceless gift, a detailed list of the problems the enemy was trying to solve. It was a negative image of the next generation of radar technology. Knowing that the Germans were exploiting the limitations of long-wave radar, the Allied research effort was supercharged with purpose and direction. The cavity magnetron, a British invention that generated high-power microwaves, was no longer just a fascinating physics experiment. It became the heart of a crash program to develop centimetric radar. This new technology, which would later be fitted to aircraft like the de Havilland Mosquito and ships across the fleet, operated on a wavelength that was largely immune to the atmospheric bending the Germans had been so meticulously cataloging. While Axis scientists continued to pour resources into mapping the weaknesses of Allied systems, Allied engineers were already building a new system without those weaknesses. The race had been reset, and the Allies were now a lap ahead, designing the next generation of radar before the Axis even realized their secret had been compromised. The supreme irony was staggering. The Axis attempt to find a loophole in Allied radar had instead directly led to its strengthening. Their grand, collaborative, secret project had backfired catastrophically. The very machine designed to find a path to invisibility had instead illuminated the Allies' own blind spots, allowing them to be sealed shut. The enemy's quest for a cloak had in the end only sharpened their opponent's vision. In the grand, brutal calculus of total war, where victories were measured in sunken tonnage and downed aircraft, the impact of a single broken machine was impossible to quantify. Yet its influence permeated the very ether of the conflict. It changed the air war forever. It ensured that the technological edge, so crucial in the war of factories and scientists, remained firmly in Allied hands. The prototype that was stamped "Do Not Capture," the machine that was never meant to be seen by enemy eyes, became the very reason the enemy's dream of radar invisibility never left the drawing board. It rested in its hangar, a silent, twisted monument to one of the war's most pivotal and unknown intelligence coups, a testament to the fact that sometimes the most powerful weapon is not a new way to strike, but the foreknowledge of how the enemy intends to strike you.